All right, let's go with it here. There's a few little things here I already set up here. So 8.2, it's called the trigonometric form for complex numbers. Last time, 8.1, we looked at complex numbers. And now we're going to fuse them together with trigonometry here. So first things first, example number 1A is graph this 2.4i or 2 plus 4i. These are the complex numbers. And so as you look, the real number, basically the x-axis are your real numbers. That's the little 2. And then the y-axis is going to be your imaginary numbers. And that is, and it's called the complex number plane. Kind of fun stuff. In mathematics as a whole, right? Let's talk about this here. There are, you know, we have x and y plane, right? Now we just learned a new one called the real and imaginary part plane, right? Cool. And so how many planes do we have? And 3D planes as well. So you have x and y like this. You have x, y, and z. And there's a 3D plane on our hands. That's kind of fun too. So, and oh, did we learn another one? What's another one that we learned? Yeah, we learned another one, yeah. So anyways, generally speaking though, in mathematics, like if you think of mathematics studied in school and all that stuff, there are 13 different graphs that we look at. But again, 13, no. We're just gonna learn one more in this chapter.
We learn more Untitled.
Did we learn polar coordinates, guys?
That sounds very good.
Yeah.
We haven't graphed them, right? Why not thinking? Interesting. Okay. Anyways, let's go with it here. So B, to graph this one, B is 1 minus I means 1 out to the right along your real axes, and then 1 down along the imaginary axis. So 45-degree angle. That's what's happening here. So I, which way does I go? Straight north. Let's go right there. Boom. It is 1 unit north. Stops there. And then the number -1. Right, because it kind of goes like this right here. It's 0 plus I, or 1i, right? And this one's going to be like that. So how about graph? And it's going to be just this way, 1 unit. There's my 1 unit at -1. Okay, are we good there? So far, so good? Jamming. Let's keep on going. Okay, so definitions here, and then tell me if you need to go back. Definitions, absolute value. Or sometimes referred to as the modulus. Look at that, that's kind of fun. So I'm going to put Z as the complex number here. That right here. And what's the absolute value of it? It's going to be R. R is the absolute value of Z, which is the absolute value of X plus I, Y, I, which really is just square the X's, square the Y's, add them together, and take a square root. We good?
Absolute value of X plus Y, L.
I. X plus Y, I.
Oh, Y, I. Oh.
We'll do one quick example here. We'll keep on going. I want to see if it, yeah, let me just check if they ask for that specifically here on the homework. It just says give the absolute value. Easy one here. All right, and even if we graph it, right? If we graph it like this right here, we go 1, 2, 3, 1, 2, 3, 4. Anybody got an answer yet?
Yeah, just, we put it in square roots, 9 plus 16. Plus 16, so there's 25, so 5.
Absolutely. Even has the same variable that we had before for the R value, right? Is the length from the origin to the end here. Okay, so we're good there. Easy stuff so far. In fact, I mean, it looks like it's like we're going to fuse it with trigonometry, but it's going to be easy. Okay, so there's that piece. And then one more definition here, and then we'll get going here. Definition says the argument of denoted as ARG of Z. How's that fun? It is the smallest possible angle, theta, from the positive real axis, not the x-axis, real axis, to the graph of Z. Whew, lots of words here. Guys, sorry, lots of words here, but we'll have to do it.
So the mean is the smallest possible angle is because that. Just how we can go clockwise or counterclockwise.
Mhm.
You want the shorter version?
Yep. Even though they're always on the origin. This way would be like that. There's your argument.
Wait, so once it goes past 180, you go clockwise, and then if it's smaller than 180, you go counterclockwise. You get the angle.
Yes. Yes.
Uh-huh.
Because you can go either way and you want the short version. So it's
Red would be this way,
Yeah.
right? That's still okay. And then going this way, I'm running out of colors here. Yep, that's already used. Orange. Okay. That way. Okay, so now let's set it up here. I think we're ready. So I have this as the setup. I have my graph going out like this. And I'm going to designate this guy as x plus yi. Are we good there? All right, all the different pieces here. This is theta. Everybody good there? Let's see, this comes down. Everybody okay with this guy being a y value? That's x. This is a right angle here. I think I are over here. Is that right? Good there? So let's see if this works here. If I designate this little guy as a point now, that would be X and Y as a point. And the fun part begins here. So if that's true, isn't this also true? Let's see. Let's see. Can't do it quite yet, actually, because if we're on the unit circle, it is X and Y, but we're not on the unit circle because R could be anything. But we do have this little guy. Everybody agreed here? This is just X over R. That we know from a long time ago.
Oh, yeah.
If that's true, isn't this true then? X is equal to R cosine theta. R sine theta. And then now we put it together here. If that's true, then this has to be true. All right, let's move things around just so we can see it a little better. This is R cosine theta plus. I don't like the multiplier of a real number at the end, so this would be just Ri sine theta. And then we could do, we could take the R completely out of here because R is repeated twice. So we'll just designate it as that right there. So this would be the trigonometric form of X plus Y, I.
We're gonna have to use this a lot.
And then, I don't know if you call mathematicians expedient or lazy, one of the two, but to write out R cosine theta plus I sine theta.
Is really quite easy.
Really quite easy for Isabel. But for others, we're like, you know what? How about we just do this here? First of all, notice the trig functions are repeated. The angles are repeated. So why do that? So we're going to even make it a little tighter. How about this? It's just going to be R CIS theta.
Cosine, I, sine.
So it's cosine I sine theta.
Was that all multiplied though?
No, it's this right here, and it's the designation from that right there. So
Yeah,
that is the same thing as that.
Oh my gosh, that's too confusing because it looks like it's R times cosine times I times sine. Okay.
I said it. I'm just looking at your book.
You're really smart and don't forget anything ever, so you're never gonna forget what that
That's
is.
not me.
Or make that.
Yes, it is in the homework, just designated like this as well. So
Wow.
that's a problem. So
I
you
will
have to
not
at least
answer
know the
anything like
form.
that.
I'm
write it
calling-
down.
I'm calling it lazy.
For this one? Okay. Sometimes, sure.
We're gonna got a couple of people still writing it down. Go for it. So let's switch forms then. Let's switch forms from one to the other. What example are we on?
Three?
3? Write in. I'm just going to write in. Trigonometric form. We're going to do a few of these here. So first one is all yours there. I should do the easy one first here. I'm going to put this as a plus sign first, guys, real quick here. Plus 1, and then we'll do the minus 1 afterwards because it kind of went a little too fast. So just 1 plus I. 1 plus I will do the super easy one. First, if you can graph it, please, because then you can kind of see what's happening here. We're gonna go like this. This guy is just this right here. So I guess I already know X, I already know Y. This is just like old basic trig again, isn't it? 1 and 1. So what's r?
√2.
√2. I go with that here because it's the square of those guys here. √2. Perfect. Okay, so I have my r value. That's what I need. I also need my theta value. So you guys talk to me here. How do we get theta?
45 degrees.
Perfect. It's just going to be tangent inverse, right? Of y over x. In this case, 1 over 1. Y is there. X is there. And of course, it's going to get more complicated. You guys talked about tangent inverse of 1 over 1, or tangent inverse of 1 is? 45 degrees. Awesome. Okay, so then if you write it the long way, as some people would like to do, it'll be the square root of 2 of cosine of 45 degrees plus I sine of 45 degrees.
Is the short way just √2 CIS 45?
√2 CIS 45 degrees.
Wait, that is kind of nice. Because we're not actually getting the values from cosine of 45, we're just using.
Mhm.
Okay,
Correct.
so CIS actually does kind of help. But I think it was still born out of laziness.
Convinced.
It was still born out of laziness. though.
Okay.
I do not respect the people who made the CIS.
Okay, let's try a few here.
Where it doesn't help in any way is if you're trying to then, do the math on
Right, correct. Yeah, you gotta put it back into form or just know what it is in your mind and then kind of do the form. So let's go B. Okay, let's see if there's any interesting things that come out of this here. B, I need to know -1 plus I.
This is kind of a random question.
Sure, sure.
But when you type in pi, how many digits?
Oh, yeah, I do not know. Yeah, I think that has to look up like a TI-83 manual and just say, what's the approximation for pi made?
That is going to be the same thing.
Maybe like 99 or something like that.
it. Same.
And it kind of doesn't matter at that
Why would it be this? It's still a 45 degree angle.
point. It's like.
R is still an equal.
Except it's actually not.
It's not, it's
Oh, do you just use that to find the
It's a
angle?
135 degree angle.
yeah, because it's
Look,
negative one.
It's a
Oh, it's
45
the
degree
other
angle
negative one.
here, but it's
Yeah.
135 on the side. But other than
You have
that,
to go
yeah.
from the
it's the same.
positive axis.
So that's that. Let's see, X is 1. Oh, X is -1, sorry. -1, 1. R is equal to?
Yeah.
Area of square root of 2. And theta is the fun one now. Theta is tangent inverse of -1 over 1. But if you do that, you get yourself?
Wait, so we just put that in our calculator.
You get yourself a -45 degrees. That's what you get, but that's not the angle.
It's just
It's
44.
45 degrees is your reference angle, and you just have.
Good. So here it is. 45 degrees is your reference angle, and then you got to do the math, or the more efficient way is if you know it's going to be an obtuse angle more than 90 degrees.
Don't use the negative.
Technically, it's the same thing, right? We just bring this down and you add 180. So you can just do, let me write it the better way here. So it's just like this right here. It's -45 because you bring it down from what you just did. You add 180 to it and you get yourself 135 degrees because it is here, right? The -45 degree angle. So if you were just to add 180 degrees, it puts you right into that angle there. You could do the reference angle and then try to figure out how to do things here, or just add 180.
This one's really easy because it's exact same as the other one.
Let's try another one here. Let's try one that you need a calculator for as well. So C. C. All right. C. Okay, how about this one right here? Gets a little bit more complicated, but not by much. We're still cool like that. All yours there. Give you guys a little bit of time. Oh, I'm sorry, we never finished off that one though, right? We never finished this one off. We never put it in trigonometric form. I got that right here. So I got myself Z is equal to square root of 2 CIS 135. Okay, now the next one here. All yours for this one. Give you guys a minute or so. You may take a look at your neighbor's paper.
Oh, my desk.
Okay, come on in, come on in. It's all yours, guys. Let's get a few examples here. Try it yourself. Hello. Good morning. Say again, say again.
Would the x just be -2 and then the y 2?
Yes, except for our value will be a little different now, I think. Because now the question is, are we on the unit circle?
No.
It wasn't just -2. It's -2.
Yeah, that's right. Hold on. So for
But
tangent,
-3 isn't the unit circle, it's 3 over -1. Somewhere.
somewhere. Uh-huh. I like that.
Well, the two's not on the unit circle.
Would just
No, but it's
be,
about -2 and 2. That's not-
wouldn't it just be 16, R would just be 4?
Yeah, it's four.
Maybe.
Now we just need to find the angle,
Mhm.
which isn't actually that bad, you just do the x. It's x over y, right? It's y over x.
Y over X. That's right, yeah. For tangent, we don't need R, right? We only need R for sine and cosine. But
That's why
But don't we need the r for the axis and everything?
we do need R for the formula itself, though, yeah. Uh-huh.
We just need two, and then take